Hi everyone, this is Hossein from EJ Academy, and in this video we're going to go over solving system of three linear equations using row reduction. In the previous video we reviewed solving system of two linear equations. System of three linear equation using row reduction method is pretty similar, but since the matrix form has more entries, so it requires more steps to solve the system of three linear equations. In terms of solutions, again, similar to the system of two linear equation, there are three possibilities. The first one is your system of equation has one solution. Each equation represents a plane in a 3D space, and the intersection of the three planes is the solution of the system of linear equations. When two of the planes are parallel and the third one intersect with the other two, the intersection are two lines that are parallel to each other. They don't intersect, so as a result you don't have any solution. The third case is when two planes are overlaid and the third one intersect with the other two planes. In that case, the intersection is a line and there are infinite number of points on that line. As a result, there are infinite solutions for the system of linear equations. For the methods here, we're going to focus on using row reduction method to solve the system of equations. As I mentioned in the previous video, you need to start with the equation form and change it to matrix form. Then the original matrix form transform into an echelon matrix using basic row operation, and from there you can get the solution of the system of equations. Now let's look at few examples to practice using row reduction method. This is our first example. First equation is x plus 2y minus 3z equals 9. The second equation is 2 minus y plus 2z equals negative 8. And the third one is negative x plus 3y minus 4z equals 15. Here you see three planes representing those three equations, and the point of intersection of these three planes is the solution of this system of equation. We're trying to find the solution using row reduction method. So the first step is to transform the equation form to matrix form. So we have the equation form, we wanted to transform it to matrix form. So it would be a 3 by 4 matrix. On the first row we have 1, 2, negative 3 and 9. 1, 2, negative 3 and 9. On the second row we have 2, negative 1, 2 and negative 8. 2, negative 1, 2 and negative 8. And on the third row we have negative 1, 3, negative 4 and 15. So negative 1, 3, negative 4 and 15. The next step is to transform this original matrix form to an echelon matrix form. So to do this transformation, we use basic row operations. These operations are swapping, scaling, and pivoting. I have explained these operations and the concept of echelon matrices in separate videos, and if you're not familiar with these topics, you can check out those videos. So to transform this matrix to an echelon matrix, we need to transform these entries to 1, and also we need to transform these entries, we call them off diagonal entries, to 0. So these entries need to be transformed to 0. To avoid undoing your progress, you need to do basic row operations in a specific order. Here I'm going to start with these two entries and transform them to 0. So this would be my step 1. And then I'm going to move on to this entry here and transform this one to 0. So this would be my step 2. And then I'm going to move up and transform these two entries to 0. So this is my step 3. And then finally I'm going to transform this one to 0. So this is going to be my step 4. So let me start with the step 1. I'm going to copy the matrix here. So in the first step, to transform this entry to 0, we need to replace the second row by R2 minus 2R1. And we need to transform this entry here on the third row to 0. So we replace the third row by R3 plus R1. And by R1, R2, and R3, I mean first row, second row, and the third row. So we don't need to change any entries on the first row, so the first row remain unchanged. So R1. And the operations that we are applying here is called pivot operation. So let's go ahead and apply this pivot operation. So we have 1, 2, -3, and 9 on the first row. On the second row we have 2 minus 2 times 1, -1 minus 2 times 2, 2 minus 2 times -3, -8 minus 2 times 9. On the third row we have -1 plus 1, 3 plus 2, -4 minus 3, 15 plus 9. Now let's simplify this matrix. So on the first column we have 1, 0, and 0. On the second column we have 2, -1 minus 4 is -5 here, 5. And then third column we have -3. So this entry here, 2, -2 times -3 is +6. So we have 8. And then we have -7. So on the last column we have 9. So -8, -2 times 9 is -18. The result would be -26. And then the last entry, 15 plus 9 would be 24. Step 2. Let me copy this matrix here. Now in this step, we wanted to transform this entry to 0. So again, we need to apply basic row operation to the third row. So we're going to use the second row for that purpose. So we replace the third row with R3 plus R2. The first row remains unchanged, the second row remains unchanged. And if we go ahead and apply this operation on the third row, we have the first row unchanged, 1, 2, -3, and 9. The second row would be 0, -5, 8, and -26. The third row would be 0. So we have 5 minus 5, negative 7 plus 8, 24 minus 26. Let's simplify this matrix. So we have 1, 0, and 0 on the first column. We have 2, negative 5, and 0 on the second column. On the third column, we have negative 3, 8, and 1. And on the last column, we have 9, negative 26, and negative 2. Let's move on to step 3. Need to copy this matrix here again. So in this step, we wanted to transform this entry on the first row to 0. So we use the third row for that purpose. So we replace the first row with R1 plus 3 R3. And also we need to transform this entry to 0. So we replace the second row with R2 minus 8 R3. We don't need to do any transformation on the third row, so the third row remains unchanged. I obtained this positive 3 multiplier here by multiplying negative 3 by negative of the entry right below this entry on the third row. This one here, which is positive 3, and this negative 8 here obtained by multiplying this 8 by the negative of the reciprocal of the number below this entry on the third row, which is 1 again. So I got negative 8. Let's go ahead and apply these operations on the first and second row. So the first entry is 1, the second entry is 2. These two remain unchanged because we have 0 and 0 here. And then the third entry would be negative 3 plus 3 times 1. And the last entry on the first row would be 9 plus 3 times negative 2. Moving to the second row, the first entry is 0. The next entry is negative 5. And then the third entry would be 8 minus 8 times 1. The last entry would be negative 26 minus 8 times negative 2. The third row remains unchanged. We have 0, 0, 1, and negative 2. Let's simplify the matrix. So on the first column we have 1, 0, and 0. On the second column we have 2, negative 5, and 0. On the third column here we have negative 3 plus 3. So we have 0. We have 8 minus 8. So we have 0. And then we have 1. On the last column we have 9 minus 3 times negative 2 is negative 6. So 9 minus 6 is 3. And then we have negative 26. Negative 8 times negative 2 is positive 16. We have negative 10 and negative 2. Moving on to step 4. Need this matrix here. So in this step, the goal is to transform this entry 2 here to 0. So I need to replace the first row with R1 plus 2/5 times R2. So I'm going to use the second row to do this transformation. And this multiplier 2/5 here comes from multiplying this number 2 by negative of the reciprocal of this number below it on the second row. So 1 over -5. The result would be 2/5. The second row and the third row remain unchanged. So I'll go ahead and apply these operations. So 1, 2 plus 2/5 times -5, 0, and 3 plus 2/5 times -10. On the second row there is no change. We have 0, -5, 0, and -10. The third row is the same, so 0, 0, 1, and -2. So the result would be 1, 0, and 0 on the first column. The second column, this 5 and 5 cancel out, and we have 2 minus 2. So the result would be 0. -5 and 0. The third column would be 0, 0, 1. And the last column we have 10 divided by 5 is 2. So we have 3 plus 2 times -2. And the result would be -1. And we have -10 and -2. To fully transform this matrix to an echelon matrix, we need to make all these entries 1. So this element right here is -5. We need to transform it to 1. So we need to also take one more step. So step 5. Let me copy the matrix here. 1, 0, 0, 0, -5, 0, 0, 0, 1, -1, -10, and -2. So my goal is to transform this entry to 1. I don't need to change anything on the first row and the third row. So on the second row, I need to multiply the second row by -1/5. So let's go ahead and apply this operation. And by the way, this operation is a scaling. So I have 1, 0, 0, and -1. On the first row and the second row, I have 0. -1/5 times -5. 0. -1/5 times -10. The last row remains unchanged. So I have 0, 0, 1, -2. And finally, I have this echelon matrix here. So 1, 0, 0 on the first column. So on the second column, I have 0, 1, and 0, 0, 0, 1, -1, 2, and -2. So you see these entries are all 1, and these entries up here and down here are 0. So this is an echelon matrix. And we need to transform it to an equation form. So these numbers you see here are x, y, and z multipliers. So we have 1x, 0y, and 0z. So as a result, the first line, we have x equal -1. And then on the second row we have 0x, 1 times y, and 0z. So y equals 2. And on the third row we have 0x, 0y, and 1 times z. So we have z equal -2. So this is the solution of the system of equation. Before moving to the next example, I wanted to show you here what will happen if you apply basic row operation in a random order. So this was the matrix that we had originally. We duplicate this matrix here. So I started with these two entries here and transformed them to 0 using R1. So this is R1, row 1, row 2, and row 3. This was my step 1. Step 2 was to transform this element to 0. And I used R2 for that purpose. So it was my step 2. And then next step was to transform these two elements to 0 using R3. So it was my step 3. And lastly, I transformed this element to 0 using R2. This was my step 4. Let's see what would happen if I start with this element here and transform it to 0 first. So if I do this one first and then move on to these two entries and transform them to 0. So I need to copy the matrix. I want to transform this entry to 0. So R1 and R2 remain unchanged, and R3 replaced with R3 plus 3R2. So for this step, I'm going to use the second row to apply the pivot operation. So let's go ahead and apply this operation. So we have 1, 2, -3, and 9 on the first row. On the second row, we have 2, -1, 2, -8. And on the third row, we have -1 plus 3 times 2, 3 plus 3 times -1, -4 plus 3 times 2, and 15 plus 3 times -8. Let's simplify this matrix. So we have 1, 2, -3, and 9 on the first row. On the second row, we have 2, -1, 2, -8. And on the third row, we have -1 plus 6, 5, 3 minus 3, 0, -4 plus 6, 2. And finally, we have 15 minus 24, -9. So far, so good, because we wanted to transform this element to 0, and we already did it. Let's move on to the next step. I need a duplicate of this matrix. So in step 2, the goal is to transform these two entries to 0. So we're going to use R1 for that purpose. So R1 remains unchanged. R2 is replaced with R2 minus 2R1. R3 is replaced with R3 minus 5R1. Let's go ahead and apply these operations. So we have 1, 2, -3, and 9 on the first row. On the second row, we have 2 minus 2 times 1, -1 minus 2 times 2, 2 minus 2 times negative 3, and negative 8 minus 2 times 9. On the third row we have 5 minus 5 times 1, 0 minus 5 times 2, 2 minus 5 times negative 3, negative 9 minus 5 times 9. After simplifying the matrix above, we would get 1, 2, negative 3, and 9 on the first row. On the second row, we would get 2 minus 2 is 0. Negative 1 minus 4 is negative 5. 2 plus negative 2 times negative 3 is positive 6. So we have 2 plus 6, 8. And negative 8 minus 2 times 9, 18. Negative 26. On this third row we have 5 minus 5, 0. 0 minus, we use the same color to be consistent, 0 minus 10, we have negative 10. 2, negative 5 times negative 3 is positive 15, so we have 17. And the last entry we have negative 9. Negative 5 times 9 is negative 45. And we have negative 54. So as you can see here, we successfully applied this basic row operation and we achieved what we wanted to do. We transformed these two entries to 0, but unfortunately we reversed our progress on this entry. That's why it is very important to keep in mind that these basic row operations need to be done in a specific order to avoid undoing your previous progress. This was all the time that we had for this video. In the next video, we will continue by solving 2 more examples. If this video helped you in any way, please hit the like button and subscribe if you enjoy our content and would like to see more.